Hi, everybody. I'm really glad to be here and talk a little bit about the work NVIDIA is doing to accelerate AI. And I'm especially glad to be doing it along with Aleksandr, who's working at Nebius, who's going to be talking about how they're working to get this technology into the hands of AI developers around the world. I think, I've actually been using Nebius systems for some of my research recently, and I've had a really great experience. And so I'm really happy to be working with them, especially today. I wanted to give, when they asked me what would be most important for this audience to think about from NVIDIA's perspective, I wanted to talk a little bit about the work that NVIDIA does to accelerate AI and why a chip could never be enough. Because I think it's important as we work together to make AI faster and make more capabilities for AI for people to understand what goes into that. At NVIDIA, what we're doing is a thing we call accelerated computing, and this is a full stack optimization of all the different pieces of technology that goes into building artificial intelligence. And of course, we build chips, but we also build systems, we build networking, we work on data center design, we work on compilers and libraries and frameworks, we work on algorithms, we work on applications. And when we think about the composition of all of these things and how they can be optimized together to provide transformational speedups to AI developers around the world, we find there's so much opportunity to do that when we are able to look at the full stack together. I wanted to give you an example not from language models to start with, just because I think it's fun to think about AI a little bigger. A project that we've been working on at NVIDIA now for quite a few years called DLSS4. We just shipped it with our latest Blackwell graphics GPUs. And what this model does is take into consideration the redundancy involved in rendering a virtual world. If you think about it, the job of a GPU when it's rendering a virtual world is to figure out the color of every pixel, and there's a lot of redundancy. There's redundancy in space that gives it structure. There's redundancy in time, how objects move. And if you could figure out how to learn about that structure with an AI model, you could remove a lot of that redundancy and accelerate the entire graphics process. And that's exactly what we've done. So in our most recent DLSS model, we actually have 3 different neural networks that are running every frame. So we have like a millisecond to run each of these frames, and each of these networks, and they have to generate a very high resolution frame multiple times per frame, and then hundreds of times per second. But the upshot of that is that we can take a rendering process that's running at like 27 frames per second and render it at 240 frames per second because we've removed so much redundancy from the process. Now, if we were to try to accelerate graphics rendering through traditional means, where you just make a chip that's bigger, that has more transistors in it, just kind of turn the crank on Moore's law, we would not be able to get a 10x speed up for graphics rendering. Because it turns out that the process by which transistors are improving has slowed down. So the only way for us to provide this acceleration is to think about the algorithm. We're actually radically changing the way that graphics rendering works by adding AI to it, and in the process, we're accelerating it by an order of magnitude. Now, this is the work that NVIDIA loves to do. In order to do this, we've had to innovate on AI, we've had to innovate on chip architecture and on software. And we've had to work with game developers throughout the world to integrate this into more than 500 different games. That's the kind of work that we do, and we call that accelerated computing. Now, we do that for artificial intelligence as well. And I think it's really interesting that generative AI is such a computationally bound problem. If you think about it, most of our technologies in the past have really been about retrieval. It's been about providing access to information. Things like search or different catalogs. When we think about like the media industry, it's like watching a movie is mostly about finding access to that movie and streaming it. But generative AI is all about rendering. It's close to it's a compute-bound workload because it has to be different every time. And so what that means is it's the world's most important computational challenge, the world's biggest opportunity to apply the accelerated computing philosophy. So just to give you a sense of how things have been going over the past decade since modern artificial intelligence really took off, the rate of change by which compute has been applied to training artificial intelligence models has really taken off. I've broken it out into two different eras here. We have the sort of CNN era, starting from AlexNet and going through about 2020, which is in blue. And then we have the sort of transformer era, starting in about 2018 and going up to where we are today. So the amount of compute that's going into this is staggering, and that means it's a really exciting place to apply accelerated computing. To give you a sense of the progress that we're making, on the left we have Selene, which was one of our clusters in 2021. It was about 5,000 ampere GPUs, A100s, about 3 exaflops of AI compute, and about 100 terabytes per second of interconnect bandwidth. And on the right, 2 years later, we have EOS. It's about 11,000 Hopper GPUs. It's about 43 exaflops of AI compute, about 1,100 terabytes per second of bandwidth. And the way that we're able to get those kinds of speedups is by this thing we call accelerated computing, rethinking the entire design, all of it, networking, chips, compilers, all of that. Our most recent platform is Blackwell, named after the famous mathematician from Berkeley. Go Bears, by the way. I'm a proud Berkeley alum. And Stanford can have a GPU later, but this is the Berkeley one. We're really proud of Blackwell. It has a lot of innovations, a lot of this accelerated computing insight that we're customizing everything about the entire data center for the world's most important AI. It has amazing new numerics that are much more efficient and save enormous amounts of energy. It has amazing new networking capabilities. NVLink scales up to 576 GPUs, which allows us to train huge models that view all the memory of those GPUs as one coherent space. We're really excited about what that's going to do to AI. Now, I wanted to talk about Jevons paradox. Sometimes when people think about acceleration in AI, they think, well, isn't that going to decrease the amount of computers that are needed for AI? Because if you can make something faster, you don't need as many computers to do that thing. But actually, what happens in this kind of situation is when we reduce the cost of something that's fundamental to an industry, the actual demand goes up. And this was originally shown back in the days when people were mining coal for the Industrial Revolution. The more efficient that they made the engines, and the cheaper the price of fuel went, the more people found ways to apply that, and so the actual demand went up. So how does that look for accelerated computing? Well, with Hopper, to train a particular large model, an MOE with 1.8 trillion parameters in 90 days, so about a quarter, we needed 8,000 GPUs and 15 megawatts for that entire 90-day period. With Blackwell, with our amazing new networking and numerics, we can do that with 2,000 GPUs in 4 megawatts, so a quarter of the power. And when we think about what that means for AI, that just makes it a lot more possible to deploy, a lot more possible to invent. Okay, now we actually train our own foundation models at NVIDIA. We call them Nemotron. Why do we do that? Well, one of the main reasons is so that we can understand the full stack optimization process. I've been telling you, in order to do accelerated computing, you have to actually understand all of the different things that go into it in order to customize the entire system for the world's most important workloads. So we train our own foundation models so that we can learn this. And our goal is really to help every business build its own AI and grow the AI ecosystem. We also have this thing called NVIDIA inference microservices, which is our way of packaging up AI models that are fully optimized for all of NVIDIA's platforms. So no matter what kind of computer you're running on, you know that you're getting the absolute fastest and most efficient inference. And that runs across hundreds of millions of GPUs that are out there already. So kind of wrapping up, I wanted to give you all a sense of what NVIDIA does in order to support the AI community. Chips could never be enough. Of course, we start with chips. We love our chips. We're very proud of them. But the work that we do is really about providing new capabilities to AI developers and researchers around the world. And that means full stack optimization. It means rethinking everything. In the same way that we have done for graphics, we're doing that for AI. In this field right now where generative AI is really compute bound and is becoming more and more compute bound, we're finding, for example, with reasoning models that the more compute that we can add into reasoning, the smarter the model gets. We feel like the applications of AI are critically dependent on this ability to accelerate AI and make it more efficient. So that's the work that we're doing. And we work with a lot of companies in a lot of different parts of the ecosystem. I think it's really exciting to work with Nebius. Nebius has been a great partner of ours, trying to make GPUs and this kind of technology accessible to AI developers around the world. And Alex is going to talk about that next.
Thank you. Hi, everyone. Thank you, Bryan. I think that Bryan just mentioned several important things about the accelerators and the software that NVIDIA created, and that was one of the foundational elements why we're moving so fast and why we as a people were able to make that breakthrough in AI development. But here we have a lot of developers who are building something interesting, yeah? And I think that when you hear that there is a great accelerator, there is a great software, you always have the question, how I could get access to that? There is always one way you can buy that. But there are also other ways. And today, actually, I want to talk to you more about how to select where to get accelerators. But before I will jumping into that, let me give you a 4-minute introduction. What is a Nebius? What actually we are doing? Interesting question. Who heard about the Nebius before? My colleagues. They know who's the Nebius. So that's why I want to start. As a Nebius, we're building AI cloud. There are several reasons why we call it AI cloud. There are several trade-offs and decisions we made while we were building the platform. But in a nutshell, what we believe and what we see as our mission is actually we want to build a platform where any AI practitioner, any AI explorer, any AI developer could find a solution for his use case, regardless his level of expertise. Because we're all doing different things. We all have different expertise, but we all want to achieve the result, success. And we as Nebius, we want to provide you with a platform where everyone will be able to achieve the success. And yeah, there are many customers who are already working with us. If you want to learn more about how we design internally, we can talk about it later. But to continue, in a nutshell, we're a company of the engineers. We have more than 400 of engineers who are developing. There's hardware engineers, software engineers. We have our own data centers. We're building them, and we have really strong and long relation with NVIDIA. From where we exist in the world, we have several offices. We have offices in the US, we have offices in Europe, but the headquarters actually is in Amsterdam, in Europe. And regarding the data center, where we have resources, GPUs, CPUs, and other different things, so we have several of them. In the US, we have data center in Kansas City. We recently announced the data center in New Jersey. We have data center in Iceland. We have data center in Finland, and we have data center in Paris. So there are plenty of data centers across the world. You can use any of them. And what makes us unique? What's our foundation? So there are several things that makes our foundation. First of all, it's data centers. And when I say data centers, we're doing data centers slightly different. So we're not just building a box with the coolers. we're actually investing a lot in research. And for example, our data center in Finland is really energy efficient. The PU is around 1.1, which means we're almost not wasting the energy. And actually, the same data center is heating the village next to it. So we're always trying to reuse energy as much as possible. And the second pillar is hardware. We're producing our own servers. We're doing a lot of research in terms of physics simulation, how the air is flowing through the servers. We design our own baseboards. We producing everything on a factory, and then we ship that as a rack. And on top of the hardware, we're actually building the software stack. That's a real cloud platform. Everything is virtualized, and you can have access to different resources. But to build that, and why we believe that we're building AI cloud, because we're building it based on the learnings that we get while we were building AI. We have our own AI team who are building different things, including models for the 300 billion parameters. And the information which we're getting from them is helping us to shift the entire platform to the AI. Yep. So let's talk about not the Nebius. Let's talk about how you can get access to all of those nice accelerators and the software from NVIDIA. First of all, as I said, first of all, let's talk about why it's important. So why actually selecting of the appropriate infrastructure is important for you. First of all, it's about the cost. Unfortunately, the cost is really important, and selecting of the wrong consumption model, for example, instead of per token, you can take GPU per hour. You can burn out your budget much faster than you would develop what you want. The second one is the team productivity, because everyone have their own skills, and you need to select the tools that will be suited to your teams. Because if you select the wrong tool, you will not achieve the results. You will be wasting time and looking for people or learning something. The third is time to market. Depending on the tool that you will select and the skills, you can have really short time to market, and you will bring your brilliant idea to the market first, and you will catch the market. Or you will be the second or third, and you are not the first. Market is already there. And the last one is competitive advantages, because the decisions that you are making is actually also influence on what you can build. So it's also important. Okay, so about how you can get an access. First of all, as I said, you can buy the GPUs, put them in the garage, put them in the data center, in the server room, where you want. But I don't want to touch that part. Let's talk about the cloud. In the cloud, you have several options. First is a GPU cloud. You can go and rent GPU per hour. You control everything there. It's only your responsibility how it will work, what you will install, how you'll make redundancy. Then you can go to the serverless GPUs. It's kind of experience where something already automated, and you probably will just bring container, bring a code, and the infrastructure, you don't see that. You just say, I want 5 containers, I want auto-scaling or something else. So it's much easier for you, but here you already lost part of the control because you could not influence on the infrastructure, on the decisions made there. And the last thing is you can get access to all technologies and accelerators if you select something as a service, for example, infrastructure as a service, where you pay per token. But here you have almost zero control. You cannot influence on a batch size. You cannot influence on a speculative decoding that was selected for you by the provider who created the solution. So as you can see, when we're moving from the left to the right, we're doing a trade-off from controlling to ease of use, from predictable cost to variable cost. And how to select one of those. So there are several dimensions. First of all, it's economical. So when you're doing a decision-making process, first about economic, how you can get calculation of the total cost of ownership, because that includes the hardware or inference or whatever. It includes people. Then it includes efficiency, how you use them. Then you need to think about budget and time to market. Do you want to go first, or for you it's more important to build an infrastructure? Think about technical things, because you have different requirements for latency. You have different requirements for the performance. Maybe you need to do some customization of the pipeline. Maybe you need customization of the model. And then integration. Do you have some system that you need to be integrated? Do you need to install something? Do not forget about operational things, because you have your own team with some skills. Can those people use that tool or not? Do not forget about SLA. Check what is SLA, what is what kind of guarantee you can get for the performance, what kind of guarantee you can get for availability, because that will influence on your user's experience that will get. And do not forget that you need to scale. And the strategic part is also important. So, do you want to use specific API that will not exist anywhere else, or you want to use something open source? Will that tool help you to get some competitive advantages that will differentiate you on a market as a company, as a product, or not? And do not forget about compliance, because different certifications, different requirements, different regulations. Once I saw a company who was starting to build medical assistant chatbot, but they started to use it with a public endpoint without HIPAA compliance and somewhere in Europe. So you cannot go with that combination, for example, to US market, just because you're not compliant with regulation. And they had to restart everything from scratch, just because at the beginning, they made the wrong decision about the tooling. And again, don't forget time to market. So if you take all of those dimensions, you can build something like that and put things that are really important for you and only for you. You can select some of them, you can select all of them, it depends. But there is no single solution for everyone. So those numbers more or less random. I put them from my head based on my decision. But your use case have different priorities. So remember, there is no single solution for everyone. You need always to do that and make a selection. And not only model brings the result of your service, of your platform, it's also about the infrastructure that you're using for this model. And when you're starting to do that assessment, first of all, you need to think about what do you have right now, what kind of tools, what kind of resources, and what kind of requirements do you have. The second step, you need to start putting those numbers, but do that from your priorities. And what is more important, do not forget to find things that is not negotiable. For example, regulatory compliance. If you need that, you need to do that. I could not, this is super priority, and I could not change that. So you need to select tooling based on it. The last thing is, do not forget that nothing constant in this world. So you're changing, your business is changing, the world around us is changing. So be ready to change the decision when the time comes. Some best practices that you can take and use. So first of all, always start with the business requirements, not infrastructure requirements. As a developer, I'm as an engineer, I really love to play with the things, with the new libraries, new tools. But if you're starting from a tool selection, then thinking how to use the tool for the business problem, that's the wrong way. You probably will not solve it. Start with the business problem, the requirements of the latency, regulation, different things. And that will help you to select right technical tools. Second, try to adopt progressive migration strategy. What does it mean? So as I said, everything is changing. Your business priorities are changing. So when you feel that something is blocking you, make a new assessment. And maybe you need to shift to something else, make another decision. And do not select one thing for everything. Because you might have batch inference, you might have real-time inference, you might have image, text inference. All of that might require different tooling and will bring different economic. So do selection based on the workload. And do not forget to use some, think about that you probably need exit strategy for one moment, because you might decide that you need to leave. And to make it easier, you can start to use some frameworks that remove the vendor lock-in, that remove specific API not available anywhere. So you try to use some frameworks that automate the process of interaction with the platforms. And the last one, but not the least, use the correct business metrics. So for example, you might start to improve total throughput of your inference service. But your users is actually waiting not the total throughput. It's important for you. For your users, it might be more important consistent performance. So select the right metric that aligned with a business metric and fine-tune this metric, not just random that you think is important. And the last thing I want to mention about the Nebius. So we know that there are different things, different access patterns, different workloads, different people around us. That's why we decided we don't want to build just one piece. We decided we build all of them. This is why we decided to build a cloud, AI cloud, where you can get access to GPUs, where you can get access to the managed applications, whether AI tooling, and for the inference service as well. So we have AI cloud, and we have Nebius AI Studio, which is inference service, with the fine-tuning, per token pricing, image stacks, etc. So this is what we built so far. And my colleagues actually asked me to do one more slide. So we are really looking for a team in the US. We have several offices here, and we want to expand our presence here. So if you want to join us and build with us, feel free to check our vacancies. And yeah, that's it from me. This is Nebius, and I hope that you will learn something today from me, and you will use those knowledge, and they will help you in the future. And I think that we have exactly time for some questions. Bryan, join me, please.
Sure, go ahead.
Yeah, I'm Marvin from AWS. I want to ask you a question about your target market exactly. So are you targeting more towards people who want to build LLMs, or is it more like the application layer, you would say? It's like about running open source models, or like building the LLMs itself?
Go ahead.
Do you want to answer?
No. I think this one's for you.
Yeah, we actually target everyone. So if you look on our clients, you'll find companies who are building big models, so we can provide cluster for several thousands of GPUs. But in the same time, because there are people who just building applications, and they're also important, we build other products like AI Studio we have, where you can get models per token, you can fine-tune per token, and then you can use the fine-tuned models also per token. You are from AWS, correct?
Yeah.
So you also have different levels of the service. You have EC2, you have SageMaker, you have a Bedrock. Let's say we're also doing different levels of the service. Yeah, and all those services that we're building, they're connected to each other. So it's full stack services, starting from the hardware till the API.
Thanks.
Yeah. Well, one thing that NVIDIA is doing for small language models is what I referred to earlier, the NVIDIA Inference Microservices, NIM. The idea behind that is that if you want to deploy on device, you can just pick up this container and know that it's been optimized for all of NVIDIA's GPUs. Of course, various sizes of language models are going to fit differently on different kinds of GPUs with different memory capacities, different generations of Tensor Core. But the reason why we built the NIM is actually quite a lot of work to optimize for every model for every different kind of GPU. And so when you use a NIM, you know that you're getting NVIDIA's very best optimization for on-edge deployment. Yeah?
So you mentioned the energy efficiency of your chips have improved, GPUs have improved. So is there anything like the green 500 is what they use for the supercomputers?
Is there anything like what?
Green 500, that's
yeah.
how they measure the supercomputer performance,
yeah.
flops per kilowatt kind of.
Yeah. Yeah. So I think that the best large-scale AI benchmarking is from MLPerf, and they have quite a few benchmarks that measure the speed at which you can train or infer these models, and I think some of them also include energy and power as well. So that's, I think, probably the state-of-the-art industry benchmark. Yeah.
NVIDIA and the AI development acceleration. And you mentioned NIMs and how those tie in.
Yes, so the kind of optimization that we would do for a model that's running on a unified memory system like GB10 is different from the kind that we would do for a big server like that are in Nebius server farms. And that's why NIM is important, because we do want to make sure that our models can run as effectively everywhere as possible. One of the things that I really love about Project Digits is that it's this tiny little box, but it can actually run some really amazing language models locally. And I always believe that the world's most important data is also its most secret data, which means that there's always trade-offs when you're thinking about how to deploy an application, and being able to experiment with things locally as a developer and know that you're not leaking any data. You don't have to worry about privacy concerns at all. I think is really important for the development of a lot of applications. And also, it's just a lot of fun for hobbyists, to play around with things at home. So we love that in NVIDIA. I think it's something that we're really excited to support.